In this video, we'll be discussing how to correct
looking at
for
nuclear
false
gauge
high
testing
moisture
of
content.
soil material for density and moisture. We've been given some Proctor data for a MAC. In this video, we will be looking at nuclear gauge testing of soil material for density and moisture. We've been given some Proctor data for a maximum dry density of 114.6 pounds per cubic foot and an optimum moisture of 14.1%. Let's begin by finding our optimum moisture range. Because we're dealing with soil, our optimum moisture range will be plus or minus 20% of our optimum moisture. To find 20% of our optimum moisture, we simply multiply by 0.2, which is just the decimal form of 20%. When we do that, we get 2.8%. To find our optimum moisture range, we simply subtract 2.8 from 14.1, which gives us 11.3, and add 2.8 to 14.1, which gives us 16.9. This would then mean that our optimum moisture range is 11.3% to 16.9%. On the right-hand side, you can see where a nuclear gauge test was done. We are given a dry density of 114.2 pounds per cubic foot, a wet density of 133.3 pounds per cubic foot, a moisture unit mass of 19.1, and a moisture percentage of 16.7%. Let's continue now by looking at the TL124 and filling in the spaces. We can fill in the data for rows E and F as that information was given to us in our Proctor data. Our maximum dry density of 114.6 pounds per cubic foot can be filled into row E. Our optimum moisture of 14.1% can be filled into row F. We can also fill in rows A through D using the information from our nuclear gauge display panel. Our wet density of 133.3 pounds per cubic foot will be filled into row A. Our moisture unit mass of 19.1 can be filled into row B. Our dry density can either be found by taking A minus B or directly from the nuclear gauge display panel as 114.2 pounds per cubic foot, and will go into line C. Our moisture content can be found by taking B divided by C times 100 or directly from our nuclear gauge display panel as 16.7% and filled into row D. The last thing that we need to do is determine whether or not our test passes. We do this by taking our dry density, dividing it by our maximum dry density, and then multiplying by 100. Our dry density was 114.2 pounds per cubic foot, and our maximum dry density was 114.6 pounds per cubic foot. When we divide those and multiply by 100, our answer comes out to 99.7%. Because we are dealing with embankment, the minimum allowable density is 95% of the theoretical maximum dry density. Because 99.7 is greater than 95%, this would be a passing test.